Welcome to Gestor. Today's lesson is about measuring instrument from grade 12 physics in 5. Let's continue about measuring instrument. Measuring instrument. In physics, especially in electricity, we may use different kinds of instruments. Some of these are like a galvanometer, ammeter, and voltmeter. And we'll see in detail about these three instruments in electricity. The first one, voltmeter. Voltmeter. A voltmeter is a device used to measure a potential difference or a voltage in a circuit. It is used to measure a potential difference or voltage in a circuit. And to measure a voltage or a potential difference, a voltmeter should be connected in parallel with other component of the circuit. Connected in parallel with other component of the circuit. And the second one, ammeter, which is used to measure electric current in a circuit. Ammeter. It is used to measure current in a circuit. And to measure a current, the ammeter should be connected in series with other component of the circuit. It should be connected in series with other component of the circuit And there is a diagram which shows both a voltmeter and ammeter. This is a symbol for a lamp, and to measure a current in this circuit we are using ammeter, and the ammeter should be connected in series with the lamp, with a switch, with a battery. This is a simple circuit that demonstrates the circuit element that consists of lamp, ammeter, and voltmeter. To measure a voltage, it should be connected in parallel with other component of the circuit, where A is the ammeter, B is a voltmeter, a symbol for switch, the symbol for lamp, and source of potential difference or a battery. Battery is a combination of two or more dry cells. Third kind of instrument is galvanometer. A galvanometer, it is used to measure very small current in a circuit, used to measure very small current, very small current. But we can use galvanometer as an ammeter and as a voltmeter using shunt resistor and multiple resistor. Galvanometer as an ammeter, we can use galvanometer to measure a large current, and the second one, galvanometer as a voltmeter. A shunt resistor, which is low value resistance, and connect a shunt resistor with a galvanometer in parallel to use as an ammeter. Connect galvanometer, shunt resistor, in parallel with a galvanometer. Hence, there is a galvanometer. To use this galvanometer as an ammeter, we are using a shunt resistor, low value resistor, in parallel with a galvanometer or a shunt, in parallel with the galvanometer. Such arrangement is galvanometer as an ammeter. And the current from the source, when it reaches at this junction point, current pass through the galvanometer, which is Ig, and current going through the shunt resistor, I shunt. Since both the galvanometer and the shunt resistor parallel, total current is the sum of current through the galvanometer and current through the shunt resistor. But both the galvanometer and shunt resistor parallel, voltage through the galvanometer and voltage through the shunt resistor should be equal. Voltage through the galvanometer equals voltage through the shunt resistor. And from Ohm's law, voltage means resistance of the galvanometer, current through the galvanometer, equals R shunt times I shunt. But we want to find the value of the shunt resistor. To determine the value of the shunt resistor, then divide both sides of the equation using I shunt over I shunt. Cancel out, then the value of the shunt resistor equals Rg Ig over I shunt. But I shunt from this equation equals I minus Ig. Then I shunt means I minus Ig. This is the value of the shunt resistor to use galvanometer as an ammeter. We have this equation. And the second one, galvanometer as a voltmeter. To use galvanometer as a voltmeter, we use a multiple resistor. Connect multiple resistor in parallel, I mean in series with a galvanometer. And diagrammatically, we have a galvanometer and the multiple resistor. Such arrangement is galvanometer as a voltmeter. What value of the multiple resistor? To find this, since both the galvanometer and the multiple resistor series, current through the galvanometer equals current through the multimeter. And from voltage from the source equals voltage through the galvanometer plus voltage through the multimeter. And from Ohm's law, voltage through the galvanometer means resistance of the galvanometer times current through the galvanometer plus resistance of the multimeter times current through the multimeter. This is equal to voltage from the source. And to determine the value of the multiple resistor, we shift this RG IG into to the left, V minus RG IG equals resistance of the multimeter, current through the multimeter. And the value of the multiple resistor, Rm, equals V minus RG IG, V minus RG IG over the value of divided Im, current through the multimeter, or I through the multimeter and I through the galvanometer equal, then the value of the multiple resistor equals V minus RG IG over IG. This is equation to determine the value of the multiple resistor, to use a galvanometer as a voltmeter. Now let's see an example which is galvanometer as an ammeter and galvanometer as a voltmeter. The first example, galvanometer as an ammeter. To use galvanometer as an ammeter, we use shunt resistor. The value of the shunt resistor equals RG IG, resistance of the galvanometer, or times current through the galvanometer over current from the source minus current through the galvanometer. And already we have a galvanometer of full scale deflection, 5 milliampere. Current through the galvanometer is equal to 5 times 10 to the power of minus 3 ampere, is to be converted into 0 to 10 ampere current, 10 ampere maximum current. If its coil galvanometer has a resistance of the galvanometer is equal to 50 ohm, what is the value of the shunt must be heated. Where do you have RG, IG, I minus IG? Substitute. So this is equal to 0.025. The unit of resistance is ohm. And the second one, galvanometer as a voltmeter. To use galvanometer as a voltmeter, we are using a multiple resistor. The value of the multiple resistor is equal to voltage from the source minus RGIG over current through the multimeter and current through the galvanometer. In the case of a voltmeter, which is the same, then we can use I through the multimeter. Now, given a galvanometer of resistance of the galvanometer is equal to 50 ohm, and full scale deflection current through the galvanometer equals 5 times 10 to the power of minus 3 is to be made into 0 to 10 volt. Maximum reading of the voltmeter, the galvanometer in this case, 10 volt. Now substitute 10 minus Rg50, Ig 5 times 10 to the power of minus 3, current through the multimeter and current through the galvanometer equal. Substitute and solve, we get 1950 ohm. From this result, as an ammeter, we use a shunt resistor, low value resistance. This is a low value resistance, and to use galvanometer as a voltmeter, we are using a multimeter, which is high value resistance 1950 high value. This is the end for today. Next, we'll continue another topic. Till there,